Dear viewers, this video presents the PV source. This is the PV source EV charger, which means that is a two-wheeler charger. This is the two-wheeler charger. The motor is a Pmsm, permanent magnet synchronous motor drive through the Zeta converter, right? Normally this video we are going to see that is the MATLAB based simulation, that is the PV photovoltaic panel is used. We are going to drive the EV electrical vehicle EV through the DC to DC converter in the Pmsm motor is used for here, right? So this is that. And simultaneously this DC to DC converter, which can be the sourced by, this is the PV source 1, and another sourced by the, that is the battery, yes, of source battery 1 and source, this is battery 2. Here if the PV power which is going to connector, which means PV which is going to charge the B1, again B2 which may be going to supply the Pmsm, or else that is the PV which can be supplies, that is the B2 battery, that is the B2 battery, again that is the B1 which may be going to supply that the PS, that means permanent magnet synchronous motor, Pmsm. So this is the basic concept. Here the Zeta is the that is the Zeta converter, ZETA, that is that the Zeta converter here we are utilizing for the purpose of that the DC to DC conversion purpose. So this is the one of the basic paper we are seeing, that is an electrical vehicle battery charger based on the Zeta converter fed from the PV array. It's a normal IEEE conference paper. This is the basic Zeta converter. This Zeta converter is simulated. Again the irradiations they are using the 1000 and 750 and 500. Same operation we are simulated. How we are simulated this operation we are going to see the step by step. See, please see here, we are going to give that is that the step input signal. This step input signal is a 500, 750 and 1000. What is that? The creation is, that is the simulation, that is 1000 watts per meter square. Please see here. And another one thing is 750 watts per meter square. Next one is that is the 500 watts per meter square, right? The same operations we are seeing here in the by using the repeating sequence step staircase step block module, right? Okay, now we are going to feed into that the PV. This PV which is having that is number of parallel string is 1, series 4 panel is connected. Again this is the PV and IV curve. What is the maximum power? That is the 1 kilowatt power for the single module. That is the total power we have going to be get. So this is the test system we are going to be considered for our work, right? Suppose if you need that is the basic temperature and 1000, here we are assumed that this is the 750 because our simulation is a 750, again which may be going to consider as a 500. So this is apply, then plot. So this is the three curves. This is the three curves. The different values of the power and the voltage we are obtained. Now we are going to see how the system which be going to obtain this operation. So this is the Zeta converter. Please see here that is the Zeta converter. What is that the available here? That is the basic Zeta converter which is available. It's a IGBT, inductor, one that is a capacitor, and another one is the diode and resistance and capacitance. Similarly, that is here we see that is the inductor, again inductor, capacitor, diode, the output which can be seen for here. So this is that the Zeta converter. This is nothing but the P and O. Here this is the P and O based, which means perturb and observe based maximum power point tracking. Perturb and observe based maximum power point tracking. So output, this is the code. This is the general P and O method. This is the general P and O method. We are going to get the value of the voltage and the current here. We are going to get the voltage and the current from here, from the PV panel we are going to get. So this value which can be fed into that our P and O method. These P and O values, that is we are going to obtain the maximum power, right? Maximum power. Okay. So what is the maximum? Based on this maximum power, again we are going to give that the suitable firing pulse of this Zeta converter. So this Zeta converter here, the MPPT which also going to achieve here, that is the MPPT. MPPT is achieved for the here by with the help of the Zeta converter also, right? Right. So again, first of all, we are going to see the circuit one by one. Then we are going to see the simulated output. So this is that the circuit. What is the EV battery is connected? This is the two batteries. This is battery 1 and battery 2. Similarly, we have connected on battery 1 and battery 2. Again, we have connected to that the Zeta converter. This is maybe output of the one side of the Zeta converter is connected. And again, that is the common point which is connected to that the electrical motor here, which is going to available the common point. Please see, this is the common point. Again, we have going to get that is the charging unit. Okay, this is the nothing but the Pmsm motor. This is the Pmsm motor. Again, this is the control circuit for the Pmsm motor. This is the control circuit for the Pmsm motor. Further, the controller which can be implemented here. So now itself we are going to see how the control action will be taken place. So this is the dual battery system. Please see, if the one battery is connected, please see, that is the very important thing. If the one battery is connected, again the another battery is connected to the load. Please, I am also going to put this the repeating sequence is 1 0 1 0 1, which means that is the 2 seconds per pulse. So here we are going to run in the 6 seconds. So the 2 seconds is one battery is on, again the battery 2 is off, again the battery 1 is on, again the battery 2 is off, again the battery 1 is off, again the battery 2 is on. So similarly, that is that the operation on and off which can be carried out by using this the control signal. So this is the IGBT. This is the closed IGBTs which are going to connect. The output of these two batteries is connected with the Pmsm, right? Now we are going to see open all the this is the 500, 750 and 1000 radiations. So we want to see that the voltage, right? So this is that the power we are going to obtain in the different power. Please see that the simulation output. This is the more important here. That is the irradiation seconds. They are using the 1000, 750 and 500, but our slot is something else different. Slot here we are utilizing. What is in our slot is please see, that is the 500, 750 and 1000. That is reverse, right? So the same that is as like that the graph 1000 we are getting that the maximum power, 1000. Again, that is the voltage, and current will be obtained by using this curve. This by using this curve we are obtained the power. Next one is how we are going to change the charging and discharging. Please see this. Okay, so this is the figure consigns, and next one figure already we are seen. This is the figure. Okay, so up to this 1.5 seconds, that is the 500 irradiation. Again, the motor we are going to maintain, that is the power. At the same time, again the irradiation value is 1.5 to 3 seconds, which can be increased. Again the power value is increased, but we are during that time we are going to change the battery from up to 2 seconds to another 2 seconds. Up to this, the battery which can be going to charging. Please see, this is the what is the current here, the current lower charging value. It in 1.5, this is the 1.5 time second, which may be increased 500 to 750 irradiation. Again the charging current will be increases. Charging current will be increases up to 2 seconds. The battery will be going to discharge mode. Again the battery, another one battery which can be come to the charging mode. So during the time of charging mode, the current which can be reversed, this can be denoted. This point which can be denoted, the battery become discharge mode to that is charge mode. This battery which may be going to charging mode to discharge mode. Up to that is the 3 seconds. That is the 3 seconds. The irradiation is reaches on its 1000 watts per meter square. Again, that is the same values we are going to maintain for the discharge. Whatever the discharge is the same, but however we are increase the what I am say, that is that the power. The this is the this paper only concentrate the one part, that is the voltage is maintained, that the constant, but the thing we have going to maintain that not only that the voltage and the power. Two things we have going to maintain here, that is voltage and the current we just going to maintain. This is the main voltage we have maintained at the constant, that is if it is the change of that, the voltage will also going to maintain. Similarly, not only for this paper output, apart from this paper output, we are also going to improve that the improved version of the simulation is here available. Yes, this simulation is improved version. So the entire simulation which can be simulated by using the MATLAB 2020 A version, 2020 A version. This is the entire setup for the PV based EV charging with a dual battery system. Okay, thank you. So this is the output.